Let's start, go ahead and build the model. So as part of the machine learning workflow, let's start loading the data first and then perform exploratory data analysis, since visualization is a fundamental step in exploratory data analysis. Followed by this, let's do the data wrangling, the data preparation, and then dive into building the model. The next step is obviously we evaluate the model performance using the classification related metrics. So, all right, as first step, let's start with importing the required libraries. So in this case, already I have included all the required libraries. And here, I have used the stat models package also. When I imported this stats model package, I was getting this error, SciPy signal tools. To overcome this, I have executed this code snippet to overcome that issue. So now if I import this stat models, I'm not getting any error. So in case in your system, when you get the same error, you first execute this code snippet. But I would advise strongly, don't execute this snippet. It is not required. First, start execute this line. If this package gets imported successfully, then you can proceed with the next step. If you get the error similar to mine, then you need to execute this line, this code snippet, to overcome that issue. So, all right, the first step is load the data. So the data file name is pychurn.cc. I just click on run. Now I could see that the column names start with the unnamed, something like 0, account, length, international plan, voicemail plan. And if I scroll towards the right side, I can see a column by the name of churn. So the churn, this column has false, false, and true in it. And this is our dependent variable. Our dependent variable in this case is churn. It is a binary categorical variable. So we have only two values in it, false and true. And this one is supposed to be encoded by 0 and 1. So 1 is true and 0 is false. We will see how we can encode as we move further. And if you look at this data set, all the independent variables are numeric variable, and only these two columns are having the no RES, the categorical variable. So now let us quickly explore the number of rows and columns. Here we have the 1840 records are there in this data set, and we have 19 columns are there. And here I already checked the number of customers, those are non-churners, and those customers already churned. So 237 customers already churned, and 1603 customers are non-churners. If you take a look at the ratio, churn rate, so 237 over 1603, it gives me 14% churn rate. The next step is I explore the data here. In this case, I just plotted the international plan in the x-axis, and the hue is churn. And if you see this chart, we can see that international plan, in this case, those customers did not subscribe for the international plan. The churn rate is less. Okay, churn rate is less, and those people subscribe for international plan, their churn rate is slightly more, on par with the people those subscribe for the international plan. And here, if you see here, voicemail plan, it is little different in contrast to international plan. When it comes to voicemail plan, those customers subscribe for the voicemail plan, their churn rate is lesser compared to international plan. Next, let's go ahead and explore the column names. So these are the columns that are available. If you see here unnamed zero, there's something weird. So we need to remove this column. And the next one is account length, international plan, and so on. The next stuff is I have explored the duplicated records, that the presence of duplicated records. I don't see any. And the next step is in case you have any duplicate records, you can use this method or function to remove the duplicate records. And the next step is check for missing values. In case you have any missing values in your data set, you need to come up with a strategy to handle that. Either you can do imputation, or you can probably check with customer and see if you can get some good data which doesn't have any missing values in it. The next step is as part of exploratory data analysis, we will be proceeding. In this case, I proceeded with exploring the outliers. Do we have any outliers in this data set? The logistic regression models are not much impacted due to the presence of outliers, because the sigmoid function takes care of the outliers, which means the tampers the outliers. But the presence of extreme outliers may impact the performance of the model, and it can lower the performance of your model. Since it is always good checking the outliers on your numerical variable. I just hit this one, and let's take a look at and on each independent variable. We don't see much outliers. It's okay. We don't see, it's fine. This data set seems to be good. It doesn't require too much of data preparation. We don't see duplicate records. We don't have any missing values. The outlier is also not so significant. And the next step is univariate analysis. This is the first step. We do it as part of exploratory analysis. As the name suggests, we explore each independent variables, and then we will take a look at it. In this case, the international plan, right? So I just used only one variable here, the independent variable international plan, and you can see that only few of the customers they subscribe for the international plan. And the next column, next independent variable is number customer service calls. If you look at here, only one customer made 674 calls so far, and two customers made 396 calls so far. And 387 customers, they did not even make a single call. And as we move further, 237 customers made three calls, and 95 customers, and 34. If you see 10 calls, six customers made. If you see here, 237 customers, they made three calls. Now let us visually look at this here. So we can see that majority of the customers, they made only one call to the call center. And the next one is zero calls made by this many number of customers, and two calls made by almost 400 customers. And next, when we do the bivariate data analysis on this international column with the churn, we can see that same thing here. This one already we have seen it. We have explored it. So the next stuff is the number of customer service calls. The interesting thing to note here is that those who made 2 calls to customer service churned at 0 to 2, 0 to 3, they churned at the same rate. Similarly, those made more than three calls reported high churn rates. If you see here, these customers made more than 4 calls, the churn rate is also going up here on par with this non-churners. Okay, and here you can see that as the number of calls are high, 5, the churn rate is going up. This is an interesting insight. The next one, let us check the correlation between the independent variables, the numerical variables. We can see here there are some kind of correlation, multicollinearity is presence here. And if you look at the diagonally, so if you need, you can simply ignore the diagonal values here, because it represents correlation with itself. in which other than the diagonal values, the one, and if you see here, this one, the total day minutes correlated with the total day charge. These two independent variables correlated, and if you see here, the total evening minutes, this variable correlated with total evening charge. So in total, we could see that four columns have perfect, four independent variables have perfect correlations between the columns like total day minutes and total day charge and total evening minutes and total international minutes and total international charge. That's what we could see here. Hence, dropping these columns, we're dropping, since we will hence I'll be dropping those four columns, right, correlated with the other independent variables. So I'm going to drop it here, and the next step is data pre-processing. Here, what I do is what I did was I just selected only the categorical variables using select t types function. And the next step is so here, in this case, we just checked how many number of customers they subscribe for international plan, how many of them they did not subscribe. And the next step is we need to perform the encoding for these three categorical variables. The one is the international plan, voicemail plan, and the churn. And here, if you look at here, in this case, so the label encoder, in this case, the label encoder converts the categorical columns into numerical by simply assigning 0 and 1. Okay. So the label encoder basically it converts the categorical values into binary. So it's 1 and 0. So after after I did this, the next step is I just checked it once again, how many number of customers, how many ones or subscribe for, how many customers have subscribed for the international plan, which is 180. Yes is 1 here, and 0 is 1660. It is always a good practice after you do the data transformation to just check the count. You do the count. The next step is in this code snippet, I just replace these three columns. I'm going to replace the existing three columns with these encoded columns. If you see here the international plan, voicemail plan, the previous column got replaced by these three columns. And if you scroll towards the right side, you can see that in the churn column, so we have 0 and 1. So now all the independent variables, all the features are numeric, and the the dependent variable churn has 0 and 1 in it. The next step is I'm going to create the variables x and y. The x is going to hold all the independent variables. If you look at here, I excluded the churn by dropping it. By default, the in place value is false, and the churn column will get excluded. The rest of the features, the independent variables, will get assigned to x. And in the case of y variable, I assign the dependent variable churn. Next, we are all set. We are able to create two variables, x and y. X is holding all the independent variables. The next step is the train and test split. With these functions, the train and test split, you don't need to divide the data set manually. In this case, I have imported the train and test split from only the train and test split from the model selection from the SQLN library. Rather than importing all the functions that are available in scikit-learn, it is convention to import only the pieces that you need. In this case, I need only train and test to split. So in the next step is the train and test split function splits the train and test data set from our original data set. If you look at on the right side of the equal sign, the train and test split takes these arguments x, y. This is optional. The test size is 0.35, which means it will split the the original data into 65, sorry, 75 and 25 ratio by default. But here I just specified the test size. We can also override the default fit size using this parameter test underscore size. And we have another argument called train underscore size. So if you specify any one of them, that is enough. If you specify, in this case, I've mentioned 0.35 for the test size, which means the remaining 65 percentage of the data will be randomly sampled and get assigned to the training data set. So the train and test split returns four values. The one is for the um, the the independent variables. These two variables will be holding the 75 percentage of the 75 percentage of, sorry, the 65 percentage of the data for the independent variables, and the remaining 25% of data will be stored in this in this variable, the independent variables value. And in this case, the dependent variable values get stored 75 percentage in this variable, and remaining 25 percentage will get stored in this matrix. These are all matrix. Okay. And the next step is feature scaling. So for the time being, I'm not going to do the scaling now. I just go ahead and fit the model directly. In order to build the model, so I created an instance of logistic regression, and binded its reference to the variable. In our case, it is log underscore rec. And then I have used the fit method. It takes the independent variables, uh, the training data independent variables, and then the training data dependent variable values here. And then it fits the model and returns the model instance itself. Look here, the instance here is the logistic which was written. And using the coef variable, we will get to know the coefficient, the slope coefficients values here. The next step is I'm going to apply this trained classifier, in this case log reg, the logistic regression model. The trained logistic model, I'll be applying the unseen data in feed test using the predict method. And this predict function assigns the predicted class label for the unseen test data set. So if you look at the ypred class here, so you can see that zeros and ones. If you see here one, wherever you see one, these customers are classified as churners, more likely to churn. Okay, and these customers are non-churners. The next step is there is a function called predict proba, using which we can predict the probability for the training data set. In addition to predicting the class label, using predict function, using predict proba, we can predict the probability. Look here. So we can see the predicted probability here. And when I view the values stored in ypred prob, we can see that two values assigned for each row here. So this is a matrix. In this matrix, each row corresponds to a single observation. For example, the customer A. Let's say this is customer A is for a customer A, predicted probability. For the customer B, this is the second row, the second probability. So why are we getting the two values here? This first value is the probability of the predicted output being zero, which means what is the probability that this customer is not going to churn? And the next one is what is the probability that customer is going to churn? We are very particular about this. What is the probability that customer is going to churn? So in that case, by indexing the value 1 here, like how I did here, if you execute this one, you can get only the predicted probability for those customers will churn. So that's what we can see here. And the next step, I'll be defining the threshold. So to map, so now the question is, what is threshold? Look here. So here, I was able to retrieve only the predicted probability for those customers churn. And here, I just copy pasted this here. On the left side, I have assigned this to this variable y pred class. And here I define the threshold. So what is a threshold? So my model, the predict proba function gave us the predicted probability for both non-churner as well as the churners. We are very particular about those customers are going to churn. What is the probability for those customers to churn? So in this case, we are converting the probability to class again here. So here, using this list comprehension. So what I did here was the ypred class. Take each and every probability and check if the probability is greater than 0.6. If it is more than 0.6, then assign 1. Those customers predicted probability with predicted probability is more than 6, to assign a class level as 1. Now the question is why we need to do this step. So why we need to create a threshold here first of all. In order to map a logistic regression value to binary category, we have to define a classification threshold. It is also called as the decision threshold. So here, let's say my model assigned the predicted class level as 1 for the churners, otherwise 0 for non-churners. So my model, just because it assigned the class level for 1 for the set of customers. Now let's say my model assigned, right? So in this case, our model assigned the predicted class level for the churners. Now the question is, what is the probability, or which all customers of those customers assigned with predicted class level 1, how many of them are at high risk? So according to me, 0.6 and above, or above 0.6, are at high risk. So this you can change it based on your need, based on the industry that you work, or based on your need. Okay, you can change it 0.6, 0.7, 0.8, something like that. So here we are very particular about, okay, my model, let's say hypothetically, my model assigned the predicted class level 1 for 500 customers or 200 customers. Of those 200 customers assigned with class level 1, how many of the customers are at high risk? Not, I'm sure not all the 200 customers assigned with the predicted class level 1 are not at high risk customers. And in order to define that, in order to know that, we need to define a threshold. So in this case, we check those customers predicted probabilities more than 0.6. They are consider them as a churners. As I said, you can play around this value. The next step is the confusion matrix. For this confusion matrix, we need to pass the test data set and then the actual value and the predicted value. The actual value is 0, 1. This was already given, okay, and this is the one predicted by my model. By passing this, we'll be getting, I just go ahead and select this one. And we can see the confusion matrix got created. With this, how do we interpret this one? So here, this is 0. The first one is the true negative, and this is false negative, and this is false positive, and this is true positive. And this is the predicted 0, and this is the predicted one. This is the actual 0 and actual 1. This is the actual 1. So actual churners, and this is the actual non-churners. And this is my predicted 0 here and predicted 1 here. So with this, what we can understand here, we can see that 560 customers were correctly predicted as non-churners. And if you see here, actually, this customer is a non-churners. My model did not predict any false positive. Okay, my model did not predict any false positive here. And if you look at here, actually the customer is a churner. One is a churner, but my model wrongly predicted 84 customers are non-churners. And if you see here, the true positive is 0. So actually churner, but my model was not able to detect even a single churner. Okay, but there is a false negative value. We could see a lot of false negative value. We need to reduce this false negative value. That is the next step we need to do it. And what we will do is we have something called confusion matrix display function is available, using which we can plot the confusion matrix in a, it's a visually looking good. So hence I'm going to use this one. Or else I just use this one. Okay, and we can see that. So whatever we see are the same thing we could see here. That is the zeros and ones, and the model predicted 560 customers are non-churners. Actually, they are non-churners. Good, but my model was not able to predict even a single customer as a churner, whereas 84 customers are churners. There is something wrong here. But when I look at the accuracy, look here, there is a function called accuracy score. You need to pass. In this case, I passed the independent variables of the training data set and then the predicted values of the training data set. And in the second line, I just passed sorry, this is my actual value. This is the predicted value for the training data set. This is the actual value of the test data set and the predicted value of the test data set. If you see here, we don't see any overfit here. But in this case, the accuracy is not much reliable because my model was not able to predict even a single customer as a churner. There is something wrong over here. And the next metrics is AUC, area under the curve, ROC AUC. And even for this, there is a ROC AUC score method is available as part of sklearn.metrics. And in this function, you need to pass the actual values of training data set and the predicted values of training data set, and then the actual value of the test data set and the predicted value of the training data set. And if you look at here, in this case, the AUC, it gives us the area under the curve value. The area under the curve value ranges between 0 and 1, but unfortunately, here the area under the curve is just 0.5, 0.52. But we don't see any overfit because both the values are somewhat closer. The area under the curve, however, the value of the area under the curve should be somewhat closer to 1. Only then we can conclude the model is doing good job. So in this case, it is not up to the mark. Now let us go ahead and explore other metrics. We will use other metrics and we will take a look at how we can improve this model in the subsequent session. So far, whatever we have created, the logistic regression model is the baseline model. The next step is we need to look at how to reduce this model. So what I did here was, before we proceed with the next topic, we will look at the RFE. There is something called RFE. We already discussed about this function as part of the linear regression. RFE stands for recursive feature elimination, using which we can do the feature selection. In this case, I have just passed the first argument of the RFE function is the logistic regression classifier name, in this case a log, right? And the 8, the this one tells us the the second argument is nothing but the number of features to select. This RFE is recursive feature elimination. It is a feature selection method. It fits the model and removes the weakest features until the specific number of features is the reached. So in this case, I use the fit method, and then the variables x and y passed here, and then with the help of support and ranking, we can understand the features that are having highest predictive power. So those features got assigned with one are considered as having higher predictive power. And what I do is here, what I did was here, so in this case, if you look here, x dot columns. Mm. So this is my independent variables, all the independent variables. This variable x is holding in it. This is the one we created at the beginning of this thing, right? Before we build the model, this is what the x and y variable we created. The columns that are part of this x variables are these independent variables. Now, what I so here, what I did was, so I just passed the RFE dot support underscore variable to this one. So this serves as an index, as a Boolean index. What it does is it selects those features got assigned with true, the Boolean value true, which means that those features are having higher predictive. Using RFE support, by using the RFE support, I was able to filter the columns that are having higher predictive power. In this case, we have 3, 4, 5, 6, 7, 8. Out of so we have started with 19 various columns in total, and then we removed 5 columns due to multicollinearity, and then it got not 5, I guess 4 columns. So yeah, 4 columns out of 19. If you subtract 4, 15, we are left with 15 columns. Of the 15 columns, my model selected only the 8 columns. RFE selected only the 8 columns. It removed the weakest features. But this one, the number of features to select this one, and this is the one. This the RFE requires the specified number of features to keep. Okay, but however, it is often not known in advance how many features are valid. To find the optimal number of features, cross validation used with RFE. But anyhow, so with this itself, we got a fair amount of idea. We can the next this is with this we can fit the reduced model. The subsequent video will take a look at how we can we will create a model too. Yeah, for the model 2, we will use these features as an independent variable, and then we will evaluate the model performance, and then we will see how best this reduced set of features selected by the RFE is effective